One, two. Ah, okay. All right. Whoa, whoa. One. Ah, ese no tiene el de la boca. Me da igual. Con tal que se oiga bien. Ok, 1, 2. A ver. Voy a poner aquí. Ahí, mejor. 1, 2, 1. 1, 2. All right. Yeah, that sounds good. Yeah. All right, we'll do it. 5 minutes, guys. We're waiting for a few stragglers, and we'll start in 5 minutes. This doesn't work that great, by the way. Yeah. Yeah, that's fine. We're going to have to worry about John here because John likes to. This is like a cage for John. This is a cage, John. You need your space. John needs his space, so I don't know how this is going to work. Yeah, it's true. I forgot to ask Eric to be live tweeting. Uno, dos. Uno. All right, folks, we can go ahead and start and get going here. So, welcome everybody to another year of Into the Box here. First day. My name is Luis Mahano. I'm the CEO of Ortus. I'm a computer engineer by trade, creator of all things Box, except FuseBox. That's not mine. Called a few things, but documentation weird is one I really love. But to start today, thank you so much for all the sponsors helping us out from Computer Know-How and Dev IT. Thanks to all the speakers that came from all over, from Europe and from all over the US as well, and El Salvador. So very cool stuff. If you thank somebody that you see here, these are the ones that put together the conference every year, so thank them. They do a great job. And of course, after the conference, we're going to be putting everything online for CFcasts and learn.boxlang.io in our academy as well. So everything will be available to you guys. As always, our tradition of Happy Box / karaoke box tonight upstairs at 6:30. So please do not be late. You're going to miss some people singing. And of course, we have our tradition, which is to introduce ourselves, what we call the social minute. I know as developers, we're a little bit weird and hesitant to talk to other people. So this is the tradition, 59 seconds to get to know your neighbor and see what's going on. So there you go, start. Morning. Good morning. Morning, Jacob. Electricity. Nice to meet you. Five, four, three, two, one. All right, all right. All right, guys. Settle down, like George says. Settle down, settle down. All right, we have a lot of things to show you. There's a lot of things that we've been working on. It's actually really exciting to share with you guys our 20-year anniversary at Ortus. 20 years of operations, and actually it's going to be June 6th, the 20th year, when I released ColdBox for the very first time. So it's very, very exciting, such a trajectory, and we have plans for so much more. So it's super exciting to see that. And with that, we want to start with our new baby. BoxLang. So this is our new box. We're so excited. We're calling this the return of the dynamic language. Last year, actually 11 months ago, we released our first version, our first stable version, after more than a year and a half of development. And a lot has been going on in that 11 months, and now we're up to 1.13, which will be released today as well. So let's get deep into what's going on inside BoxLang. So this is a state of the box since May of 2025 when we released. 13 minor releases. We've done over 82 new features, so we've already started to innovate a lot now. 258 improvements into the runtimes and over 500 bugs being squashed in that period. We've gone from 12,000 to around 16,000 automated tests, from 30 repositories to about 86 repositories of code around the stacks. Between 30 modules that we started with, we are over 55 official modules now. We started with about 10 contributors. We're over 30 contributors into the platforms. 5 native runtimes that we started with. Now we're over 30 runtimes as well. And we started with 0 cloud server offerings, and now we have over 18 cloud server offerings. And we started with 1 IDE, and we support over 7 IDEs now. And this is only 11 months. And what has been really exciting is a lot of companies already migrating their applications, and a lot already running in production. So it has been a really fantastic thing to see how the trust has been built up and how very big companies and renowned companies are now basically moving to BoxLang. Our team has grown as well, and this was very important for the longevity of the project. So a lot of people involved in BoxLang, which is exciting, and a lot more coming. We've seen a lot of great quotes from people in the community already doing production deployments and working with BoxLang, some even since the alpha days. So that has been pretty exciting. So it has been a real doozy, I would say, for the last 11 months, trying to make sure that all the folks are running in production correctly. So that's pretty exciting. Through that 11 months, we've managed to start with one ecosystem for BoxLang, and now we've ended up with a complete interop between 3 ecosystems. So if you're running on BoxLang, this is a great advantage that now you have the availability of 3 ecosystems to interact with. We've also gone to other areas in Java land, and we've had great success, and this has been a tremendous thing. We've gone to Sweden, we've gone to Germany, we've gone to several places in the US, several conferences, and BoxLang has been at that center. We've given talks with Brad and with other folks of the team, and we've even had folks coding on their phones in these Java conferences on BoxLang. So it has been a really nice thing to see how Java developers have adopted BoxLang exclusively. I mean, when we went to this last conference in Sweden, they were already building applications with BoxLang AI. So that was great to see. Brad got interviewed as well. So it has been a real incredible journey to be going to these new conferences and expand our community to other areas. We started with one IDE. We support over 7 IDEs now out of the box, which has been a really good thing for developers, especially IntelliJ. One of our core goals when we started BoxLang was to create a multi-runtime architecture. This was really important. We were not just at the server anymore. We really wanted to go to other places we had never been able to go. And when we launched last year, we had several that we launched, from the operating system to Java integration, Java scripting, command box, of course, a brand new mini server idea that came about from Brad's brain, which is a scary thought. Lambdas, Jakarta integration for word deployments, Docker, and Jacob creating the language server protocol, all on BoxLang. And throughout these 11 months, we also released 4 more runtimes. We released the GitHub Actions runtime, the DigitalOcean one, Spring Boot, and actually Google Cloud Functions are available now. And today, we get to release 5 more. So you guys are going to be privy to 5 more new runtimes that we're releasing today. So the GitHub Actions was a great way to provide continuous integration. It's available. It can install command box already, ForgeBox integration, modules integration, available for any type of integration in GitHub. The DigitalOcean one is actually powering a lot of some of our websites now. You can actually launch a BoxLang application with only as little as $5 a month. Very, very easy. You clone, you code, and you deploy. Extremely easy to get everything out with DigitalOcean and our new runtime. This came about from our Java friends that wanted to use a templating language based like BoxLang in their Java applications. So we actually now have a Spring Boot runtime. And this actually allows you to seamlessly work with BoxLang inside of a Spring Boot application, do your entire views in BoxLang, full web scopes availability, and this has opened a ton of new doors as we're going into the Java space because their templating languages really are not that great. This is our new one, which is the Google Cloud a few weeks ago. So it basically starts what we're calling the BoxLang serverless framework, and it allows you to code once and be able to deploy in any serverless provider. Right now it's Google Clouds and AWS Lambda, but Azure functions are already in a pull request, so they will be available in the next coming weeks as well. And we also have starter templates for these. You get the template, you code, and you deploy. We even built all the continuous deployment for you guys, especially the Google Cloud functions, which is really nice. So why don't we unveil one little runtime right now. So we've been working on this for quite a while, and it's now officially available, which is the BoxLang desktop runtime. So this one is really exciting. This allows you to actually create desktop applications. This one, we have plans for 2 runtimes for desktop. This one is based on Electron. The other one is based on JavaFX. The JavaFX will come a few later this year. This one is based on Electron, and it's available now. The starter template is available for you to start coding and start creating your own desktop applications. There's even a loading screen that we provide for you guys for your apps and desktop. We provide all the hooks for you to create it, and we even provide a theme for you to create your applications at the desktop level. Okay? And we also have a ColdBox template as well, so you can create a ColdBox-based or an MVC-based application for the desktop. And with that, we also created our new BoxLang Admin desktop. So I'm going to give you a sneak peek of what the BoxLang Administrator looks like now. And it's available now as alpha. Okay, so now you can get that QR code. We'll do a press release around it, and you can basically start managing your BoxLang applications with the new desktop application. So maybe I need to mirror here. Give me a second. Uh-oh. Enter the AirPlay code. No. Javi, how do I mirror there? Oh. All right, how about that? Better, right? All right, so this is the new BoxLang Admin. It's a desktop application, as you can see. And you start it up. It works at the operating system level. And we always wanted to do administrator for BoxLang, but we didn't want it to do it in such a way where we're going to have another attack vector when you deploy it. So this works as a desktop application. This is actually a ColdBox application. And this is the new admin. You can see a snapshot of your operating system runtime, how many runtimes you are managing, if you have plus or not. Notifications are built in, so we can actually push notifications if we need to. It can give you warnings from your runtimes as well. As you can see, this is your notification center. We have different settings for the administration. It actually runs, obviously, on the command box. It has a few encryption pairs because it will allow you to talk to remote servers using these certificates that we generate for the administrator as well. And you can actually target a local CLI as well. We have a local REPL as well. So this is cool. We've always wanted to do this. So now I can actually code here in the administrator, and it's using my operating system runtime as well. So if I needed to test something against my local installation, then I can do that. And this actually is using our Monaco IDE. As you can see, it actually connects via server-side events as well. So this is all built in BoxLang, okay, with a nice history. And this is a great tool for you to test something locally. Okay. We have our different runtimes that we can manage. Again, you can basically register different runtimes with the different configurations that you have, with the different types. Different types expose different things. If there's any action around a specific runtime, it'll tell you as well. And then let me go into this operating system runtime and manage it. So once you start managing a runtime, you'll get a snapshot view of what the engine looks like. And remember, this is not the running engine just yet. This is what's on disk, what is the actual configuration of the engine. I can clear compiled classes. I can clear a bunch of different cache items, get a snapshot of how that engine is configured. I can see how many modules are configured. And this one, I don't have any at this point. But you're going to be able to manage the modules for that. You manage the log files very easily right here for this server, and I can actually go into them, right? So I can actually start managing all these log files. I see one that has a little bit more, this one. So I can actually see warnings, info, debug, traces, do a live tail on those log files from here, right? Do searches. You have full access to the actual server logs here. The server configuration as well is available to you here, and you can actually export your entire configuration as JSON, which is the boxlang.json. You can actually import a JSON file as well, and everything is version controlled. So all of your configurations for your servers are versioned. And as soon as you create a new one, you can actually view them, and you can see that specific configuration. Or you can roll back to that configuration if you need to. And then if you're in a Plus subscription, all these will go up to ForgeBox. And then you can synchronize from any machine and bring down all your configurations as well. So if you look at the configurations, you can see all the runtime configs, all the paths, everything. If you change something, it keeps track of it, so it doesn't save yet. You have a chance to maybe configure everything and then save and create something. So if I want to turn trusted cache on, I can turn it on. I can manage my resources. I can manage the application settings. I can manage my logging. I can actually see all the default loggers that have been created. If I want to change the runtime logs to now do debug, I can change them from here. If I want to create a new logger for my application, I can create a new logger from my application right here. We can manage data sources to create new data sources visually instead of doing it through configuration. Caches as well. If I want to register a new cache with a new provider, all that is provided for you as well. Executors, so you can manage all the different execution pools, the ones that we ship and the ones that you create. Scheduler, this is how the actual scheduler works inside BoxLang, so you can choose which default executor, which cache is going to use as well. And we introduced scheduler files, so you can actually choose scheduler files to execute globally. And then your scheduled tasks as well. So this is new on 1.12. They live inside of your configuration, and you can add a task now. You can say, this is my nightly cleanup, right? And then I can choose where it's going to run, right? And this one is just like you had before, right, in this case. You can add groups here. You can start it paused. You can do cluster modes. You can choose what schedule, whether it's in a specific interval, or we introduced also cron expressions, different constraints, HTTP and authentications, different outputs, so you want to control the output of the scheduled task. Error handling, if you want to manage it, you want to do retries, you want to do refires if there's an exception, or you want to pause the task, right? We've done a lot of work for scheduled tasks to make them really easy to manage, and all from here as well. Watchers, this is something that we're going to introduce in our next section, so I'm going to skip it and tell you about a little bit later. Our modules, so you can configure the different modules, and this is still, like I said, in alpha. Right now it's still in JSON, but then we'll have a UI per module as well. And security as well, if you want to disallow certain components, disallow any bits, etc., and our experimental flags. So the whole entire runtime is here at your disposal. And then in our next iterations, you're going to see here a connect. And the connect will basically do a secure connection with your runtime if it's deployed. And you have to have another module installed called the BXadmin module to do secure communications between them. And that will allow you to actually send the configuration to those servers, get actual statistics from them. And we have a lot of insights planned in the coming months for that approach. But this, and only to communicate, you're going to need your key pairs. And that's why everything is encrypted and secure in order for you to manage your servers. And everything can synchronize to ForgeBox eventually if you have a Plus edition. So that's a sneak peek into the admin. It's available for you guys to play around with. Another important aspect that we started this year is that we actually started conversations with Florida International University in Miami, Florida, and we started a pilot course with 56 students this spring. So we had 56 students learn BoxLang and contribute to BoxLang, and the entire Google Cloud Functions runtime was built by FIU students. And now the Azure runtime was also built by FIU students. Okay? And this has been a great pilot program. They actually did all the AI middleware, audio and image in AI as well. But now this course has been accepted by FIU. It was a huge success by them. I'm going to be meeting again with them in August. And now they're making this part of the university, which is incredible. So that means that in the fall, the new computer science classes are going to provide BoxLang as a course. And we're going to have over 100 students collaborating to BoxLang every semester. So this is a huge thing for us. And this was such an opportunity to impact the new generations and the longevity of the language. And now we have students basically involved and actually creating real things that now everybody's benefiting from. So this one is a big deal for us. And with that, we entered, of course, the age of AI, right? Which BoxLang, we released our first version last year here at Into the Box. We discussed the problems with AI. The integrating AI can be extremely complex sometimes. It's not only about calling a language model and that's it. You have other components, right? Memory, autonomy, how do you deal with tools, how do you deal with guardrails? It's a fast-paced world, right? Emerging standards. And that's what we wanted to bring with BoxLang AI. We wanted to bring a whole gamut of tools in order to facilitate AI integration into your applications. So this is year 2 of development. We're now on our 3.x series. We have a unified LLM provider API for over 15 providers, memory and RAG capabilities for over 20 providers, document loaders for over 30 providers, fluent AI pipelines, autonomous agents, tooling, and so much more. So I'll give you a sneak peek of everything that we built. And of course, everything is documented. We even have an MCP server for our docs. We have a bootcamp course available, over 700 tests, and 50 examples for you guys to learn from. And we provide now the entire gamut of multimodality for any LLM that supports it, from chat to audio to transcriptions to translations, and in the bleeding edge, images. And and movies coming soon. We've gone from a simple chat to a very, very extensive capabilities for multiple providers, structure output, EC-JSON, EC-XML, native BoxLang tools and objects, streaming, asynchronous pipelines. Okay? We introduced audio integration, so you can actually do AI speak from text and produce a chat agent that can actually speak to you. So now you can actually create agents that talk back to you. Transcriptions and translations as well. You also have a lot of tool integration, and we actually released a global tool registry in our last version, which allows any module developer to register tools within a BoxLang instance, and then any agent can use it. We introduced the concept of MCP servers and MCP invokers as well. So this allows you to actually create MCP servers extremely easy, and also be able to invoke MCP servers extremely easy with just a traditional BIF. Okay? I really wanted to bring the concept of completable futures into AI, and we created what we called AI runnables or AI pipelines. And this allows you to create these fluent pipelines, as you can see from the code, where you can actually start composing, right? What is going to happen when you create a message, when you target a specific agent, a model? You can do transformations. You can do things asynchronous. You can do things synchronous. So there's a lot of great pipeline information into BoxLang AI for you to create your AI applications, as well as your agents. And agents have grown quite a lot. And in the latest version, you have huge amounts of complexity available to you very easily, from creating agents with system instructions, the reasoning loops, connecting to multi-memories, which was important for us, to connect to multiple models, and being able to have different tools in the tool registry, to sub-agents. Now you can actually see the path of agents. You also have skills now available to these agents, and middleware. And this was important: human in the loop, guardrails, flight recorders. There's so much available to you now for you to create these solutions. And skills was a big one. This is where really AI shines, is when you can teach it through skills. We even have a new BIF called AI skills, so you can create your own skills and be able to teach your AI agents how to actually do things correctly. And because of this, we're basically announcing a new initiative today called skills.boxlang.io. So if you actually go right now to skills.boxlang.io, this is our central skills repository. This is curated by the entire team. We have over 200 skills already available that we curate and keep updating as we are programming. So the AI doesn't have to know how to do something specific in BoxLang or in command box or in ColdBox. It will know, because we've taken the time to create all these curated skills. So this is available. Everybody can contribute. We even have trust levels as well. And of course, everything's curated and maintained by the team. So that's a little intro of what we've been doing with the BoxLang AI. We have a full session later on, either today or tomorrow, I can't remember. But if you want to learn more about everything that we're doing and all the different agents that we're building, please come by. And with that, I want to give you to Brad and talk a little bit about language.
He didn't say what kind of language. Hopefully it's appropriate language. Good morning, everyone. I can't actually see you from here. I just see the light. Don't go into the light. So we're going to review some things in the BoxLang framework. Obviously, when we designed BoxLang from the ground up, we started with a collection of services. We wanted to have a solid foundation as framework authors to have a language that you could really build on top of. So we have things like our data source framework, our caching service, our component service, and that's all kind of what the underpinnings are of BoxLang, all managed by our global services, which of course are extensible via the modules. So we've done a lot of enhancements since the version 1.0 that we released about 11 months ago. Our BoxLang compiler is one of the sort of core components of this. We're really trying to push for making it easy to do sourceless deployments. We think that's a secure and more performant way to be able to deploy code. We want to have better tooling around that. Be able to compile optimized bytecode, support mappings, and we now have 3 different boxpilers, which is what we call our BoxLang compiler, the boxpiler. We have the just-in-time compiler, which is what you get right now. You change a file, you refresh the page, or rerun the script, and it compiles. We also have a no-op compiler, so you can completely pre-compile your apps, you can ship them in production, and you can not deploy a compiler at all. So it's literally impossible to have a remote code execution exploit because the runtime has no compiler component. That also means you can't use the evaluate function, but we think that's a good thing. And then, of course, we have the ability to do the Java boxpiler as well and the ASM boxpiler. And then we have our BoxLang compile CLI tool, which can compile classes in place for your deployments. In the last year, we've had over 500 bug fixes, 250 nearly improvements, over 80 features we've added. We've made some massive improvements on reduction of the amount of bytecode that we generate. You can see in the graph, this is a comparison of compiling the ColdBox framework, which has about 206 files, and we used to generate almost 3,000 class files, and now we've reduced that down to only 206 class files. The ColdBox framework used to be about 20 megabytes of bytecode. Now it compiles down to a little over 6 megabytes, and the compiler performance is even faster now with those improvements. So we've done a lot to speed up the parsing and compiling across the board. Done all this in only 11 months. Another thing we focused on performance is our queries. This is one of my personal favorite things, is queries. I really love those, and we are significantly faster than the other CFML engines. We are about over 17 times faster on average than Adobe and 5 times faster than Lucy. And I have a whole blog post that shows all the queries I test. I have a whole array of different aggregate grouping queries that test every feature of queries with like 1 million records. So we've done a lot of improvements there. If you use queries, that's really good. We've also been improving things like just creating CFC instances. This is some measurements of creating 1 million instances of a simple CFC, and you can see we're a little bit faster than Lucy already, and we're about 3 times faster than Adobe on that. So we've really been trying to improve performance all across the board for tuning our apps. Also, these are some measurements of just startup time to be able to start up the engine using the ColdBox and the TestBox test harness. You can see that for the startup time, ColdFusion takes about 4 minutes. BoxLang takes about 30 seconds, right? So that's about 85% faster. The engine size, as opposed to 169 megabytes on disk, our runtime is about 8.5 megabytes. So the amount of jars we're unpacking on disk is about 95% smaller in this comparison. And from RAM usage, the same test, Adobe uses about 768 megs of RAM, and BoxLang starts up only using 128. So everything's optimized, smaller resource usage, and faster startup times. And then this is some head-to-head comparison of our parsing and our compiling, our bytecode generation. There's two different tests, one comparing us against against Lucy, one against Adobe Cool Fusion. And so you can see that we are about 3.6 times faster when it comes to Lucy. This again is compiling the ColdBox framework as an example, so about 200 files. About 6 times faster than Lucy and about 20 times faster than Adobe Cool Fusion. So those initial hits to your application, when everything's all being compiled the first time, we've really optimized that to be as fast as possible. We have a bunch of language enhancements. I won't go too deep into these because I'm going to cover all these in my talk after lunch today. We have destructuring and spread. We have the ability to, you see a little syntax there where it says ... args. It's able to take that args array and pass it in, kind of like you do with argument collection to our function. We can spread a structure as well. Then on the second example, we call the greet method with ... person. That takes that person struct and it expands it into the arguments as well. We can also do the same thing with struct literals. We have our little struct literal there with ... that passes that in as an argument collection, and the same thing down below. So it's basically the same behavior as argument collection. This is a really common syntax in JavaScript and other languages that we've added in. We have struct shorthand. So the line that says config equals, that's a shortcut for saying host : host, port : port. If you want the value to be the same name as the struct, we have this nice little shortcut syntax. We also have destructuring. This allows you to extract keys from a struct and set them into variables. But instead of doing that in multiple lines, you can do it all in one line, where we have the struct on the left side. Well, it looks like a struct on the left side of the equal sign, and I'll go into that more in my talk later on. And you can also provide specific custom names to the variables when you do destructuring. And the same thing with array destructuring. You can take an array and you can grab elements positionally and set those into local variables all in one nice line of code. The range operator is brand new. We didn't copy this from CFML at all. It's a BoxLang specific feature. This allows you to essentially create arrays on the fly without having to loop over. So if you need an array with 1,000 items for some sort of test, you don't have to loop from 1 to 1,000 and append to an array. You can just do 1 ... 1,000 and you get an inclusive array. So that's basically an expression that evaluates to the array automatically. And it can be with variables. So we have a ... b that expands into an array starting with whatever the a value to the b value is. So ranges are pretty cool. And then we also have the ability in for loops to capture two things for arrays, both the item and the index, without having to have an additional assignment inside to take the number and get the item from the array. And then as well with structs, we can say for key value in produce. So you can grab both the key and the value all in one go. So it's just nice little syntactic sugar reducing the boilerplate that you're coding with. Framework enhancements, we've added a lot of stuff. We have our JSON logging, which is really huge for a lot of containerized deployments for your console logs to be emitting JSON, but you can then be pulling into some sort of stack that's analyzing that. We have the ability for pretty JSON, so you can be outputting JSON in files or the consoles that are formatted, nice and easy to read. And then we have our HTTP streaming and fluent builders. So here we have a new HTTP BIF, which we can chain nice methods to build up the equivalent of what would be like a CF-HTTP call. So I can say I want to hit my API, I want it to be a post, I want this JSON body to be sent, and then we call our send method and it fires off that request. But it's just a nice fluent way to interact with that. We've also added state tracking, which basically means connection pooling automatically. So if you have an API-heavy application, we're pooling those connections behind the scenes for better performance. We also have server-sent events. This is a sort of a low-budget alternative to WebSockets, where you have kind of like AJAX calls or server-to-client calls that just stay open for a long time and keep flushing out additional data. And so we have both server and client implementations, so you can have an emitter on a server side, which is sending packets of information over this, and then you can have on the client, even your server can be a client, consuming server-sent events from another server, and that's all possible from our Fluent HTTP builder. We have a post here, we say SSC is true, and then our onChunk method is executed every time a new chunk of data comes in, and we can stream data. And we're already using this in the administrator that Luis was demoing earlier to have these real-time log files and real-time interactions, and that is all added in. We also have our Fluent SOAP builders. For the lucky people out there still interacting with SOAP in the Big 26, these are nice fluent things. We have the URL. We can invoke the methods we want. And so those are a more modern way to wrap up the SOAP stuff. I wasn't supposed to hit next. I had a couple more bullets on that last screen. What were they? Come back. I have to go all the way back through them. There we go. Oh, yes. The last couple things that I meant to add are we have the cast as operator, which I'll also cover in my talk after lunch. It's basically a more modern way to do essentially Java cast, to be able to take a value, cast it as another thing. We also added a bunch of new array member methods, thanks to Eric Peterson. We took a bunch of the cool stuff he had in his CF collections library, and we've made those core member methods. So things like chunk, flat map, group by, reject, unique, zip. A lot of these come from other languages like Python and things that have a lot of cool helper methods. So we've added those in as core functionalities. Our assert statement also has an optional message you can provide as well. And then I already mentioned those for loops. Okay, now I can go to my next slide. Okay, and then last thing is the runtime UDF type checking. We've also added the ability to turn on and off the type checking for arguments and return values, which is something that CFML does, and we now support that as well. So in production, you can have those type checks on in development. You can turn them off in production for faster performance if you like. Okay, we've added some really nice logging things. You can now capture any Java library's logs. You may be using some Java library that's spewing stuff into the console, much like our JDBC library tends to do. You can capture any logging category and redirect that into our logging framework, so you can choose which of the log files you want that to go into. And we even have a black hole logger provided, so if you just want to shut up some Java library, you don't want to see its logs, you can just route them over to the black hole logger, and you'll never have to hear from it again. So dealing with the Java logging is oftentimes really tricky to do in CFML, so we've added some things to do with that. We have the ability to have custom namespace providers for our get system setting, and get system setting is a method that we had introduced in command box and then moved into ColdBox, and it's just a way to get your Java system properties and your environment variables, and now you can have providers that pull those from maybe like an AWS secret manager or some sort of external source to give you better secret management. We have our there you go, and that's what that looks like. We have our form and query array conventions now as well, so if your URL variables or form variables have the square brackets on the end, those get parsed in as an array as opposed to a comma delimited list. Okay, so we've added a lot of enhancements to BoxLang modules as well. We've needed most of these as we go through and are writing our modules. You can write your BoxLang modules in Java or BoxLang, and I'm talking about this in my talk later today. We create mappings for you. We've added a new public convention, so if you have a module that you want to be able to supply some JavaScript or some public page that someone can hit as part of the module, we have a folder dedicated to that, so it's kind of obvious what's the public things, what's the private things. We want to have security first there. And then we also have a new bin folder convention where when you install BoxLang via like BVM, we have a bin folder that's registered in the system path, and then any module can register system level binaries, either a shell script or a bat file. So in the same way you would globally install like a node module, you can have a BoxLang module that's just a top level binary you can call from inside of your terminal. And that's all controlled with a box.json. Okay. Mini servers had a lot of enhancements. It started out as a super duper simple server, but we've added a lot of stuff to it. There's a new JSON format you can use to configure the whole mini server if you don't want to use the environment variables or all the JVM arguments. We have virtual directories. There's a new health check endpoint if you're using it inside of Docker. It's automatic. It supports WebSockets and Stomp support. We have support for all the undertow options. We have warm-up URL support, automatic protection of hidden files. We're now loading .env files out of the box in the mini server. And then, of course, we have our .boxlang.json convention. So it's getting a lot easier and a lot more powerful to use the mini server. And then now we also are introducing BoxLings, which is named after a tool called Rustlings in the Rust world. think I said that right. And this is basically a new interactive learning tool, and we built it because we were going to all these Java conferences this year, going to DevNexus and going to JFocus, and we're talking to Java developers who have never heard of BoxLang or even ColdFusion for that matter, and they say, what does this language look like? How do you use it? How do you write hello world? And so this is an interactive terminal application. It's on GitHub. You can clone it, run it with BoxLang, and it'll open up on the terminal, and it has 28 lessons and about 129 exercises that are all test-driven development. So you open up the file, as you change the code, you hit save, the watcher in the terminal instantly runs the tests, and you keep iterating until the test pass, and you move on to the next exercise. So it's a really fun way just to brush up on BoxLang or to learn BoxLang. And so we're using that in conference now at our booth for people to come up and learn what BoxLang is, and you can also play with it. And with that, I will give you over to Mr. John Clausen.
Well, as Brad said, I mean, this is a lot of this stuff is all in the last 11 months. And so one of the things that we've also really enhanced over the last 11 months here is the BoxLang async ecosystem. So I'm going to talk a little bit about what we've done. We've added a whole bunch of convenience features for fluency to make async operations in CFML and BoxLang more fluent and faster. So, okay. So let's talk about the BoxLang async framework. Right now we have 4 major sections that we're focused on. The first is the scheduler service, and Luis touched on that a little bit. The scheduler service has the schedulers itself. It has the tasks configuration, and also as well as the ability to dispatch jobs one-off if you want to do that. You also have the watcher service. This is just added recently. We have the directory watchers. You can do additional operations on create, update, delete. And then we also have the async service itself with its executors, virtual, scheduled, cached, fixed, and custom async executors. And last but not least, for one-off async operations, we've tapped into the Java API and have the Box Future as part of the framework as well. So let's talk about the scheduling and task framework. We can write schedulers now in BoxLang, in Java, or both of them. We can use them in the CLI, the web runtime, the Lambda runtime, and we have global schedulers or specific application schedulers. You can now define those schedulers in your application BX or application CFC file with this schedulers. So it makes it very easy to create and deploy new schedulers within your application. We also have the ability to dynamically interact with those schedulers. So instead of having the CF schedule tag, as you might be familiar with, or having to have it in the configuration or in the CF admin, you have the ability to programmatically and fluently interact with the schedulers. Schedule start, shut down, restart, stats, get the list of the schedulers, get all the scheduler objects themselves, and then also get the core Box runtime async scheduler service and interact with that as well. So your ability to interact with the async scheduling service and framework is virtually unlimited. And now, this year, we're also introducing the BX schedule component, similar to CF schedule, but on steroids. It can create your HTTP task easily. It can persist in the task.json file. We offer the cron syntax, which is fabulous, and it's also great for creating webhooks, endpoint pings, callbacks, and more. You can bring your tasks over from ACF and Lucy, and then you can enhance them further from there. I really like the cron scheduling because it adds a whole another level of configurability to the schedule component. And so you can see here we have the cron-based scheduling, for example, where we can specify a cron time. We also have the ability to update and delete those tasks via the BX schedule component, and then pausing and resuming those tasks programmatically whenever you see fit. List all of our tasks. You can see here now we're going into kind of the fluency of it, and then publishing the output to disks or adding date time constraints as well. We can also limit those executions. So we can say, I only want to repeat this 5 times on an interval of 86,400 seconds. And then exception handling is much more robust than what we've been previously used to. So that's the schedule component, but wait, there's some more. We also have, you can see Luis used the slam. We have the BoxLang file and directory watchers, which you know, in the past we've had to deal with the event gateways. They were very clunky. A lot of folks didn't like using those, so they ended up using Jenkins file watchers, and then they dispatched a task when those file watchers were there. Now we've just taken this, we've integrated all of this into the framework. So the BoxLang file and directory watchers, now there's no need for those convoluted event gateways of the past. We can create them in BoxLang, we can create them in Java, however you want to do that. You can source control them, test them, and just love on them all you want. You can use in the CLI, you can use them in the web runtime, the Lambda runtime, and you have the global watchers, which you can define in BoxLang, or just like the schedulers, you can use the this watchers convention to add watchers in your application descriptor itself. In addition to that, we've also set them up so that they can respond to different events. The created event, modified event, deleted event for any files that are in that directory. We also have different listener types, so you can specify a listener as a closure, as a structive closure, or assign a class that you want to be able to use to execute the listeners for all of those events. And that runs on our virtual executors platform. Now, how do we interact with those dynamically? We've added an entirely new set of BIFs just to allow you to interact with the schedulers directly so that you don't necessarily have to define them either through the BX schedule, or excuse me, the watcher structure in your application. You can go ahead and create a new watcher, and then from there you can call start, stop, restart, is running, is stopped, get all the information on those. And as well, the nice thing is that information and those metrics are going to be visible to you in the administrator as well. But you can get the paths, you can get the listener, you can get all the statistics around those watchers and what they've done, and log them or track them in any way you see fit. So that's the watchers and the schedulers, and those alone are very exciting. It's a lot of work last year. But we've fluency enhancement. So Run Async was a fairly simple implementation in CFML, but what we've done with Run Async is we've taken it and we've now allowed you to have a much more fluent interaction and a much more specific interaction with async operations in BoxLang. So you now have the ability to specify closures, and you'll notice in BoxLang, this is in pure BoxLang. Whoops, what did I just do here? I just went back to the admin demo. Okay. You'll notice here that this also uses the, you can either use the standard equals lambda, or not lambda, closure, lambdas as well. You have the ability to do peek, then, handle errors, and you can see as well that we also now have the ability to do a get, check if it's present, in other words, whether or not the result is actually there, and if it is, do this, or output the error as well. So you have the ability to do your running, but also block and introspect the outcome of that before you try to deal with any try catches in the UI. And one other thing we've added, which I'm super excited about, I did an entire workshop webinar on this, is virtual threading. It's one of the features that's available in the modern JVM that wasn't available in Java 8, Java 11, and one of the, a lot of the times we were, the engines have had to go back and keep support or maintain support for Java 11 and couldn't really implement this. So we've added support for virtual threads, and we've added it across the runtime and all of the parallel operations that you're used to in CFML. How do you use them? You use them just like any other thread. So you just simply do your normal thread component, and you specify virtual is true. And what not familiar with virtual threads, you can take a look on CFCAS or learn.boxlang.io. There's an entire webinar about those, and also Scott Steinbeck will be doing a presentation that touches on them as well. But effectively what they do is rather than having the overhead to create the platform thread, they simply create a virtual thread that's tied to the current running thread. There's virtually no overhead. So for things like I/O tasks, waiting around for an HTTP response to come back, you can speed things up dramatically. You can also use them in any of the async operations that are available. So any of your array map, array filter, array each, any of those, you simply specify the third argument. You can specify it as a named argument or specify it as a third argument, which in this case is my array map. Here's my closure. It's parallel, which is true, and the third argument true. If that's true, it's not the number of threads. If it's a Boolean, means that it will be processed in virtual threads. And we don't have to specify a number because virtual threads are effectively unlimited. And a great quote I like, John Wish was actually modernizing some of his code, and he just posted in the channel. He's like, "Holy smoke, Batman! Just change the parallel array map to use the virtual flag, and it's about 3 times faster." And he was processing, I think, upwards of 1,000 items. So it was a significant performance gain just for that. So let's talk about, that's our async frameworks that are available, and we've made a ton of progress in the last 12 months. Let's talk about BoxLang Plus, because over the past 12 months, we've introduced a ton of BoxLang Plus modules, both to provide parity with the CFML space, but also to add additional features into BoxLang. So what is BoxLang Plus? BoxLang, we're always going to be professional open source. The community edition is always going to be free. It's licensed via Apache 2. We also have the 2 commercial subscriptions. One is BoxLang Plus, and one is Plus Plus. Now, one of the other things we did was we didn't want to deal with any of the janky old restrictions on cores or memory or anything like that. So your licenses never will have restrictions on cores, or whether or not you're running a software as a service, or whether you're doing multi-domain, or how much RAM you have. None of that will ever be a factor in the licensing of BoxLang. We have 2 plans, though. BoxLang Plus, which is professional support with an SLA. Enterprise modules and features. You get all the BoxLang Plus modules. There's no restrictions on those. You have a dedicated Slack channel, priority patches, cache connections, Redis, distributed caches with Redis, MongoDB, Elastic, Couchbase, etc. And then you have additional enhancements with PDF, AI Plus module, a ton of different modules we'll touch on in a moment. And then the Plus Plus description offers everything you get in Plus, but offers you an enterprise level SLA, a dedicated account manager, video support, in other words, the video Zoom, screen share, and get support live. And then in addition to that, you also get 20% off any consulting fees or any work that you ask Ortus to perform for you on behalf of you. So this is the list of modules that we've developed in the past 12 months. The first one being the Plus module itself, which is the controller module for all of the other Plus modules. We've developed, all of these are included with every Plus for Plus Plus license. They all offer professional support, and you get exclusive features like distributed locking, vector memories, PDF tooling, more advanced PDF tooling, insights, dashboards. So we've developed the Plus module, the Redis module, the Couchbase module, a new CSV module, which is similar to the spreadsheet module, but is specific to that type. We've also just released, these have been in alpha and beta here for a while. I just bumped releases today of the compatibility for SOAP and compatibility for REST modules. So we now have parity with ColdFusion and Lucy's REST and SOAP capabilities for web services. So those are now out today as well. And coming soon, these are currently in the process of development. We're going to be offering the BX Search module, which will give you that parity for CF Search. But rather than use the implementation, the hard-coded implementation, whether it was Solar, or whether it was Lucene, as Lucy used, we're going to actually offer multiple options on how you want to handle your back-end search. So you can either choose Elasticsearch, OpenSearch, Melisearch. We'll probably develop an adapter for Solar or Lucene if you've already got an investment in those technologies, and that will be coming out soon. The next one, and as Brad touched on, we've now updated the Get System Setting BIF to be pluggable with providers, will be a BX Cloud. Now this is going to go beyond S3 because most of our focus in the CFML world on interactions with AWS, for example, have been focused around S3 and storage. But we're going to actually develop a BX Cloud platform with a common unified API that can plug into AWS. It can handle your enhancements to interact with S3, with secrets, to use the get system setting, for example, to pull your environment from the AWS, ECS, and more. We'll integrate with the platform and DigitalOcean on the applicable offerings that they provide. So those modules will be developed. Look for alpha and beta releases of those respectively in the next 6 months or so. And now we're going to turn you over to Jacob, who's going to talk to you about runtimes and tooling.
Hello? There we go? Okay. There was multiple clicks. All right, see how overwhelmed I am? I can't even, all right. So first I want to take a second to talk about the BoxLang VS Code extension. We've been working on this for the past year or so. We extended this from the Cold Fusion one, and we've been making a lot of enhancements to it. We've been adding extensions to the inline documentation. We've added the inline web server with debugging. You have the ability to run BoxLang and CF code directly within VS Code. Like I said, the built-in debugger, they can do CLI debugging, web debugging, command box debugging, Docker debugging. It's really helpful for that. And then we've also added the language server, which is allowing us to add more analytics to your source code to be able to help you with things like linting and formatting and things like that. We are, with 1.13, we're releasing the BoxLang formatter, which is kind of inspired by CF format and pretty print. It's completely powered by the BoxLang, the BLAST, our abstract syntax tree. It's compatible with the CF format JSON configuration. We are extending it with our own version called BX format, but we're fully compatible with the CF format one, and we also provide a tool for converting from one to the other. And this is a big thank you to John Berquist, who helped us get this off of the ground and has kind of been consulting for us with it, which has been really great. And so that is in 1.13. It's part of the BoxLang core jar, so you can actually, if you have that installed, if you update to the latest snapshot version, you'll be able to run that and get started with it. I'm also going to share about the IntelliJ, which is actually been built by Eric Peterson, our very own, and he's done a great job of building that up and sharing it. Thanks to the language server, it actually has all of that syntax stuff right off of the bat. So if you open up the IntelliJ, or if you install the IntelliJ plugin, you'll get a pretty similar experience to what you have in VS Code right off the bat. So props to Eric, he did a fantastic job on that. Language server, we've been enhancing that and growing it over the past year. We're at over 600 tests, and we're continuing to add those each iteration. We've improved the memory management, the performance, the speed, and we've added dozens of new rules, and we'll continue to add more of those as much as we can. We've also added the formatter into the language server, so it can communicate with VS Code and give you instant formatting like when you save. But that's currently behind a feature flag because formatting is a powerful thing. And that needs more testing before we start formatting all of your code for you. Big thank you to the community. One of my favorite things about the language server project and the VS Code extension is how community-oriented it is. It's something that people are using each day when they code. And so I really appreciate your feedback if you run into any issues or if you have ideas for improvements. I'm happy to hear that and incorporate it. All right, BoxLang Debugger, we're on version 2. Of the BoxLang debugger, we did a complete rewrite and moved it into a BoxLang module so that we can take advantage of those features. We've made improvements on the performance. You now have the ability to write dump directly from the debugger into your VS Code editor, which is kind of a cool feature. And we have a lot more features planned for the debugger, like inline hints, the ability to interact with data sources through VS Code, a lot of cool things like that. All right. Very quickly, I'm going to talk about a few more new runtimes that we have for you. And in order to do that, I'm going to introduce something called Matchbox. This is a new custom virtual machine built for the BoxLang environment. Matchbox is kind of an interesting project because it's going to be able to allow BoxLang to go to entirely new places. Things like WebAssembly, WebAssembly Docker containers, ESP32 devices, native images, as well as a Matchbox-based mini server. It's a project that's developed in, whoops, went too far. We'll just keep going. Oh no, now I went too far again. All right, well, Matchbox is written in Rust. There's a little bit of a delay, and I'm all right, we're going to start from this one. So, okay, there we go. So, like I said, we'll be able to take BoxLang to new places. It's a new virtual machine written in Rust. It has instant startup times when you run it. And it is the same language, just a different virtual machine. It's still BoxLang, it's just not on the JVM, it's on the Matchbox VM, right? So we're talking about integration with the BoxLang ecosystem, not replacement. And then one additional kind of interesting thing is that Rust actually has tools to be able to have interopt with a JVM if you have it installed on your system. So that's a feature that we're actively working on, and you'll be able to interact with Java still, even if you're running on Matchbox through the JNI. Because it's native, we can deploy anywhere that Rust can compile to, which is a lot of different places. We're also building what's called a native fusion application structure, which allows you to write Rust source code and have it automatically pulled into your BoxLang application running on the Matchbox VM. So if you run into a situation where you need absolute bare metal performance, we give you an escape hatch to be able to do that and then go right back to BoxLang. We also add we have a JS build target, which will create a WASM bundle for you, but then also generate a JavaScript bridge so that you're able to seamlessly communicate between BoxLang and JavaScript. Just like you have Java interrupt on the JVM, you can call browser libraries, you can pass back JavaScript values, you can call BoxLang functions from JavaScript. So it makes BoxLang a first-class citizen of the client-side environment. You can even go so far as to write Alpine.js applications with BoxLang components, which I'll have a talk later today where I demo some of that. We also are planning to support BoxLang modules. So you can use CommandBox to install BoxLang modules or ForgeBox packages and bring them into your Matchbox application because it is BoxLang. And then I mentioned the Java interop through the JNI. So Matchbox can already run on a regular operating system or on an ESP32 device. We have a web runtime that allows you to run your templates, and it's mini server compatible. We do have WebSocket support, and we're working on integrating that with SocketBox. And the entire runtime is very, very small. It's about 5 to 6 megabytes, and that is everything. It doesn't depend on a single thing beyond that to be able to do that. So the runtime plus your application might be 12 megabytes, something like that. Pretty exciting. WebAssembly. We'll go into this in more detail in my talk later, but WebAssembly is very secure, very fast. My talk is at the very end of the day, so right before our party. Yeah. And we also have a JavaScript target, which is truthfully at the bottom it is WebAssembly. But like I said, we provide some sort of bridge for you to be able to easily communicate between the two, because WebAssembly right out of the box only communicates through arrays of integers, which is a pain. All right, so that's Matchbox. We got a lot more to talk about that later. But for now, yeah, thank you.
All right. Well, pretty exciting. A lot of stuff going on. We've been very, very, very busy for the last 11 months. And it's kind of crazy to think that it's only been 11 months. And we have a lot of years planned and a lot of things planned. So it's very exciting that to present, again, another 5-year roadmap of all the exciting features that we're bringing. We now have 2 virtual machines, 2 brand new worlds to attach. We're also announcing that our Lucy extensions now are entering maintenance mode. They're no longer in development. And we're even offering right now a way for you to come over for free, and we even help you for free to migrate. So with that, I was going to end, but why not introduce something else new? So let me give you a sneak peek. Since the whole rage is about AI, let me introduce to you the new BoxLang AI dashboard. This is something that we're working on right now. This is a visualization of how AI can be integrated into your infrastructure. It'll give you a snapshot of your agent fleet, everything that you've built, MCP servers that you've built with their health status, any type of alerts, any type of those tools that you're building and give you statistics. You can actually go into agents and actually see all the agents that you built and register into your registry. You can go into an agent and actually see its performance, what type of latency it has, success rate, check pointers to do save operations, how it's configured, parameters, options, system instructions, if it has any connected MCP servers, agent hierarchies now, so you can actually hierarchy these agents, all the tools with its performance of the tools inside of the agent, the middleware that is configured for guardrails or logging, the types of memories, and this is something very unique in BoxLang AI. You can attach multiple memory units into an agent and actually clear the memory for here or import memories. The skills that have been seeded inside of the agent are available to you. All the different runs that the agent is doing so you can keep track of them. A full configuration snapshot so you can actually verify that what you've done is correct. And our brand new flight recorder middleware. And the flight recorder is great to actually see what's going on inside of every run. So you can actually see everything that's happening that the AI is doing behind the scenes, even try to estimate token amounts that it's using. And you can see the system, the user roles, what exactly happened, the responses, how many tokens were used, what type of tool result came back in. And we're also, thanks to JPEG, going to be adding a 3D visualizer. So you're going to be able to map everything inside a call and actually traject it and traverse it. You have the MCP servers that you can manage and see how they're performing. These are your servers that you've exposed with the different configuration and statistics, all the different tools that are available, the resources and the prompts, and the method breakdown of how they're performing. Right? So you can actually see each of them. And then if there's an issue with that MCP server, you can pause it right here using our SSE integrations, and now that MCP server will stop taking requests. MCP clients is basically you going out to the world. It'll track the performance of that for you, and it'll actually see specifically those endpoints, how they're doing, what tools it exposed, what prompts and resources, and the request log. So you can actually debug and say, oh, this has an exception. Why? And it'll keep track for those exceptions when you're making those MCP client calls outside of your doors. You can visualize the tool registry by namespace if you need to. The global skills, so you can actually see what are the skills that are being used globally by all of your agents. The event stream, so you can actually be bored one day and actually see, okay, let me see all the tool events that are coming in, all the memory events coming in, etc. And this is live, everything using server-side events that we have available, so you can pause and resume them. And the AI log, so this is specifically for developers. You can actually go in and say, give me all the errors in the logs, tail it, is it's tailing it live or not, refresh, search, etc. And our vision of cost, this is something we're dreaming of, is to provide you a cost management if you are using external LLMs to give you specific spend by providers, because the agents can be consuming different providers, trying to be setting up a budget if you need to keep track of it, spend by agents, so you can actually track how many tokens they're consuming in and out, and different daily spends. Again, these are a lot of assumptions because they need to publish how much they charge per token and per model, and being able to have a trackable database here as well. But at least this is the vision that we're seeing for BoxLang Plus coming to you. And as well as settings. So if you actually want to test something really quickly, right, you can come in here or say, you know what, I want to log my requests to the log file and my responses right now because I'm in debug mode. I can do that, and immediately I'm going to start getting feedback in my logs. I can manipulate the audio settings and the image settings from here as well. So this is our vision of what's coming for BoxLang AI Plus. Everything is already available to you, but this is just visualizing what you have available. So hopefully that'll be a nice little sneak peek for you guys coming soon. And I promise there's no more. It's over.
There's always more.
There's always more. But that's BXI Plus. Hopefully that's exciting for you guys that are starting to get into AI development. We've been doing it for quite a time now, and we're very excited about it. And our offering is quite big and substantial. So with that, thank you. Start your day. Tons of great conferences. Tons of great stuff to show you in the next 2 days. Enjoy your time, and we love having you here. Thank you. Appreciate it.